peel back, but if you look, you can see sort of the brown, meaty, striated muscle, and you'll see those as well on the models pretty clearly, the actual insertion of those muscles. You did learn last week some cranial nerves that are associated with those muscles, so just go ahead and go review those, because like trochlear, oculomotor, abducens, those are all associated with those extrinsic muscles. All right, so once we're in our eye, we cut off our cornea, right? That's this domed structure. In preserved specimens, the preservative makes it cloudy and stiff. So if this was an alive cow, you would see it being clear. And then we come back from the cornea to this white fibrous layer, and that's our sclera. So the sclera is very tough, it's very fibrous, and it surrounds the whole eye. So it's not just the front up next to the cornea that is the sclera, it's the rest of the eye as well. Once we're inside, we can see this structure here, and then our, hang on, I don't want to break that, but this one isn't very good. Okay. We can come back, we can see the opening, so this oval opening, that's our pupil. I know it's a little difficult to see, but this oval opening, in cows it tends to be oval shaped, in people it's just distinctly round. You've seen cats, right? You've seen goats. Goats have a vertical one. And the size of that pupil is controlled by the autonomic nervous system, so there's not a lot of voluntary control over the opening and closing of the pupil. Some people who are like have mad meditation skills and like are living in Buddhist monasteries, they generally can figure out how to make that happen, but it's not typical. This ring here of striated structures, those are the ciliary bodies, and the ciliary bodies are the structures that contain the muscles that actually are able to change the shape of the lens. So that's these striated structures, and coming from those striated structures to the lens is a structure called the suspensory ligament. So you want to be aware that these muscles aren't in direct contact with the lens. There's actually a structure that extends from them to go to the lens. And this membrane, I'm not sure if that runs over the top of the lens. It's not typical to see that. There are some eyes that have lenses not in them but with them, so I think they're kind of over in that area, and it kind of looks like a weird shaped jelly bean. And again, in preserved specimens it's very stiff, so that's not typical of what you would see in a live eye, right? So then now we're behind the lens and we pass into that posterior segment. So if we're here in our posterior segment, we can see our layers. Here's our sclera, that layer. It's been kind of stained black by the choroid. And then this sort of, gosh, I don't know what adjective to apply, but this thin dark layer, that is the choroid. So the choroid is vascular. You can kind of see a little bit of that as we peel it back. And in the cow, we can see this sort of iridescent layer, right, this metallic layer. That's not something that we find in human eyes, so that's the tapetum. And that is a reflective surface that helps reflect light back to the retina to give it kind of another chance to get caught by the photoreceptors. And you see that in animals that are, you know, nocturnal or hang out at twilight, right? So dim light animals generally have that. We do not. We are daytime creatures. The retina generally appears like a tan or a yellow membrane laying on top of that choroid, so it's a little hard to pick up, but you can see this sort of felt-like thin layer that is not there. It's just laying flat, and if we can get it kind of picked up, you'll see it kind of bunches together. It's very thin, it's really delicate, and it's not actually adhered to the choroid, right? The only place that it's actually adhered to the choroid is right here at the optic disc where the optic nerve is leaving. So if we were to peel this up all the way, it would come up all the way around the eye. because it's just a thin membrane. And the vitreous humor, the gel-like substance that fills this cavity, the sort of viscosity of that is what pushes the retina out onto the choroid and holds its shape. So the vitreous humor is really key in your ability to see, because you don't want a wrinkly retina. You'll never get your vision, right? So that's kind of what we're looking at. On the models, you're going to see a few more structures like the macula lutea and the fovea centralis that's associated with that sort of center of visual acuity where all the photoreceptors are very concentrated. Yeah, I would say be prepared to identify those on the real specimen and on the model, a lot of those internal structures.